Hey guys, welcome back. This is Always back with another video on the channel. In this video, I'm going to be talking about Angular best practices for structuring your code. Let's talk about building blocks of Angular applications. We have modules, services, components, pipes, and Sass files. When writing Angular application, we need to make sure we break down our code into smaller pieces for a specific functionality. For example, you will have services which are going to be used in different modules, reusable components, pipes to format your data. After looking at this presentation, I'm going to take you to one of the projects that I've been working on. That's an enterprise level software. And I'm going to be showing you how I structured the code, which will give you an idea of how you can structure your code and break down your code into pieces, which are really good and clean performance and scalable code. I've got one announcement to make. We're providing web development services and online in-person training on various technologies like Angular, Java, Python, web development, mobile application development. So if you're interested in any of these services, contact Umar Jamil. I've given these details in a description as well. When writing Angular application, there are common modules that every application requires. For example, every application needs authentication, a core module, main dashboard area. If it's a mobile application, then you might have like a navigation dashboard type area. So in authentication, you have login, registration, reset password, forgot password, or mail confirmation pages. A core module is usually the module where we write our services which are common to other modules as well, which are going to be used throughout your application. Guards are there as well. We write reusable components in our core module, common pages or common modules. We have a dashboard area where we'll write our application specific pages and navigation, user interface, and templates. We have some common services in our Angular application. For example, HTTP service, which is responsible for making all the CRUD operations in your application. The best thing about writing an HTTP service is that you make sure that any API call that you make that goes through this service. So if there is a problem with your API call, you know where to go and look for the problem. We need to have error handling service, which is responsible for showing errors to the console, or if there is a message for a user that he needs to know, then we can write that in error handling service as well. Every application needs some sort of helper functions like date and time, data manipulation function. If you're probably using Lodash to do the data manipulation, you're gonna make sure that you write all those helper functions into utility service. Now, there are a few key points to this. For example, you are using Lodash 4.0, and if you use functions from Lodash directly into your code or into your components, then the problem you're going to face is when there's a time for newer version of Lodash, then you're going to have like 20 different places to fix the functions or write a new code to make it sure that it's compatible with the newer version of Lodash. So encapsulating your common functionality into one place will help you to upgrade your application to the latest code. We need a storage service. Basically, every application needs some sort of storage to store data into local storage. We can write that storage service which is responsible for one specific thing, which is storing data into local storage. Now, why should we worry about code structure? There are a few key points to it. It's easier to debug, it's clean code, performance, scalability. Now, after this presentation, we're going to go to PyCharm and I'm going to show you the actual structure of the code that I created. It's like a skeleton for enterprise level application. So let's go and take a look at the code. I will show you, or I will share some key points why I did this. And when you write your code, or if you're a beginner Angular developer, it's surely gonna help you a lot. Okay, so I am in a project which I want to show you the structure. So first of all, I'm going to take you to the browser and show you what application it is. It's basically have authentication module, a main area for a web application. For example, if I go to this URL, you can see that's a dashboard there. It has some more pages. Also, we have some navigation going on here. Also, if I go to just a plain localhost 4200, it takes me to home module. Let's go back to the code and let's start by exploring. So as we know, the app folder will have our Angular code. We have this app module where we write our main router as well. So if you want to write your application, you probably need app module because this is the main module where your application is going to start. So just for convenience, I wrote these routes within this app module TS file, but the best way to do it is by creating another app routing module file, which you can put these routes there. Now, one thing that you want to make sure that all of your routes are lazy loaded. In Angular 8, we have this load children and we have this way of importing other modules. Basically, lazy loading means that when your application starts, it's not going to load all of these modules and it's not going to wait for all of these modules to be loaded. Now, if anybody clicks on one particular button which is supposed to take you to this auth module, that's the only time it's going to load. It's going to help your application to start up faster and it's going to give you some improved performance. So this is like the app module. Now what I do is I import some of the common modules which are going to be used throughout applications. For example, this fuse module here using for root. So this configuration will be used throughout my application. So this is like just an app module. So in app component.ts file, all I have is a router module. Now this is the main module. Now what I do is I break down modules into the module folder. For example, here we have a home module, we have this authentication module, and then the main dashboard which I named clocking. And then I have a separate module which is responsible for the layout. Now we are providing a layout. Let me just go back to the clocking. And here is a dashboard. For example, in a layout module, you need a sidebar, you need a toolbar on the top, and if your application requires the footer, then you need that as well. Now, you should be writing these specific components into your layout modules, and layout module will be responsible for rendering these components. This working area is where your other pages are going to load. So let's go back to the code. Now here I've created a layout modules which I'm importing and exporting all different types of layout that I created. For example, if I go to setting button, I click on vertical layout 2 or horizontal layout, as you can see, it's going to change the whole UI and it's going to make it horizontal layout. We have this vertical layout like that, and then this vertical layout which is basically by default. Another benefit of is this running these separately is you can have like a turn on or off. So here's a button where I can turn it on or turn it off and then fold it as well. Okay, let's go back to the code. Now here I created all of these 3 folders where I have this module. I'm loading all the modules that I require. For example, footer module or navbar module or toolbar module. All of these are separate modules which are just loading into layouts and then doing their own CSS thing to be able to render on specific part of the page. Okay, that's where we talked about some layout, how I structured it. Now, every application needs some common functionality. For example, I go to the core folder which I created and I put guards, some common modules and services into this folder. Let's talk about services first. So for example, your web application is going to make API calls. Now, if I take you and open the HTTP service here, As you can see, this service is only responsible for making an HTTP call, and it's the only thing it's gonna do. And I want to make sure that any call that I make throughout my application, that has to go through this request call function, because if there is a problem with my HTTP call, it's easier to debug and I know where to go and find the problem. And I don't make this service messy. All I have is request call function and handle error function. So basically, if there is error, it's gonna pass that error to this handle function. If there is no error, then it's just basically going to make an HTTP call. So that's my HTTP service, and I don't write any API call or any function which is responsible for making any API call anywhere in my application, and I will use these functions to do this job. Now, there are errors throughout your application sometimes. Now, what do? Basically, in error service, I created some codes like, success code, or now I moved these to somewhere else. Don't worry about these for now. But for example, we have some success code or client error code. And then within this function, I created a function called which error. And I have a error code, and I switch from customer error. It's like enums that I typed. So if API call, sends back an error code, then I know it matches to my backend, and I don't have to, worry about what kind of error is that. So I know how to deal with it. So this function will basically look after all errors. Here's a user notification. If there is a notification that has to go to the user, then I will use this function. So that's the only thing that I wrote here. Now, every application needs some data manipulation. I'm going to show you one really important key point here why I did this. Now here I am importing these functions from Lodash, like for each or isEmpty or find every. Now it's okay to import these functions into your component or into other services, but there is a catch here. For example, I'm using Lodash 4, and in Lodash 4 the name this function is empty. Okay, now there's a newer version of Lodash available, let's say version 5, and they have renamed this function to yesEmpty, for example. Now if I have imported this function isEmpty in 20 different places of my application, obviously that would work. But when I'm gonna go to the upgrade part, I will have to find 20 different places to actually update or rename this function. Now what I did is I imported all of these functions from Lodash, and I wrote getters for those. Now if there is a function which is renamed, I don't have to worry about going through my application and finding that function where it's used. I will just have to rename this text here, and my application will continue working. So I like to encapsulate the third-party function within my functions and use them from there, so update is easier and you know where to go and look for a bug if there is one. So that's like a Lodash service that I created. Now storage service is responsible for just storing, stuff to my local storage. So here I'm storing this. I'm using this service, util service here. So I'll show you the util service as well in a second. But here I have some functions like store, save token, get token, remove token, and other stuff here as well. Okay, so all these functions are doing is saving, retrieving stuff from a local storage. Now you gotta make sure that you use this function. You could simply write this line to remove item from a local storage, or just this line of code to get item from local storage, but that's a bad practice because your code is going to be messier, and if there are 10 places that are using this line of code, in case that changes, then you have a lot of places to fix that. Okay, Now, I like to write a util service which basically responsible for manipulating data or, doing some custom functionality for my, application. For example, I would like to decrypt something, then I write decrypt function and I encapsulated this AES from crypto.js. Now, I could definitely use this directly in a component or any service that it was required. But again, for making sure that there's only one place that decrypts and encrypts, I would have to encapsulate that third-party function into my own function, and I know where it is in my code. Easier to debug. Like, I needed to have random number for my application, so I create a random function and then return that from here. So anywhere in my application, I will just use this function, pass a digit, and then it will return me the random number. Now, another thing that you should do for best practice is all your constant, you should go into one file. So here I have like a constant where I have an enum for API method. I'm exporting that, and auth endpoints. So all the API endpoints that are used in my application, I'll put that into one auth endpoint so I could use from here. So application interfaces, stuff like that will go here. So these are like services that I wrote, but I'm going to continue writing more services just to give you an overview how you can break down your code into different pieces. Now, in the core modules or some sort of pages, like 4 or 4 pages require you when you have some server error, then you have like a 500 error that you can basically use this anywhere in your application where there's a 500 error occurs. So here you wrote this is like a common component that can be used anywhere application. Now, in the modules, I like to put all the third-party modules on my own reusable functionality. So in the material module, what I did is I imported all the material UI components that I was using in my application, because I don't want to go and import these everywhere in my application. Like every component needs like for example, a table module. I'm not going to import that there because that's not really good. So what I did is I just imported all the modules and then exported them. So all I had to do is just put that one module wherever I require, and everything will be available for me. Now, there's a better way to pass in what module that you want for one specific component. That can be done as well. Now, here's a form library that I created. I've done the video on my YouTube channel. If you want to have a look to create a reusable form library on object base, so you create an object instead of writing an HTML, it will create you a form. So forms require some component, like input component that I wrote within the component function. It requires some interfaces. Then I created an interfaces folder to write all those. It requires some service like form control service. So you can see how am I structuring the code. Now, when it comes to your main functionality of your application, you break down into smaller pieces. Like authentication will require some pages. Instead of writing them into one big module, I broke down these, because once the user logs in, I don't need this code. I don't need to keep this in my memory. So because I'm lazy loading these modules, this will not be sitting into memory and I will be able to use less resources. So in auth modules, I created all the auth specific interface, and then the pages like forget password, get started, login, mail, confirm, stuff like that. Yeah. So if I need a login, okay, then what I'll do is I'll show you one thing. So I created this login functionality. In the on submit, I will use the function from my authentication service. So here I will have a services folder where I have an auth service, which basically going to talk to my HTTP service to send the request. So here you go. This is HTTP service, and using the same request call function, and that function is smart enough to accept some arguments and act upon them. So here I have like all the services, login, current user, register user, stuff like that. Now I could write here in TypeScript file, but that's not a best practice. You shouldn't be doing that. You shouldn't be creating a service to do those tasks for you. Now that's like a structuring of an authentication module. Now here I have a special navigation TypeScript file, which is basically an object using this views navigation. So here what I'm doing is I'm defining some objects where are going to be rendered as a navigation. So here we look at all of these navigation are happening from that file. So later on, if I want to have another navigation, I will just have to copy paste and define the path here. Okay, that's the navigation that I keep it separate. The clocking is like my main functionality. So I have like a clocking routing module, which I'm lazy loading all the pages separately. So for example, here we have a pages. Okay, every page is like a module on its own to just keep the code, clean. I'll just create this on duty module. Let me show you a dashboard module where I have this dashboard, and then here you're simply saying that I'm just importing this route. I could create another routing file, but it's just a matter of one line. That's why I just didn't really care about it, and I just wrote that one line right on the top and within this module. So yeah, now there are other stuff that you need to make sure that any third-party library that you use, you encapsulate that into your own function, because it's going to help you to debug, and it's going to help you to scale or upgrade your application easily. Okay, that's like a brief structure of how you do it. But when it comes to main functionality, the more you break down, it's good, but you gotta be able to understand the requirements of your application. How big is it? So depending on that scenario, you will break down your application into different modules. So I'll be creating a lot of Angular tutorials, guys. Also, we're providing some web development and online teaching services. I'll drop a contact detail for Umair under the description of this video. Okay, thank you so much for watching, and I'll talk to you guys in the next video.